This video is supported by the NDLR and the Department of Mathematics in NUI Maynooth. In earlier videos we talked about what it means for a sequence to converge, and in those videos we said a sequence converges if you travel sufficiently far down the list of numbers to it begin to stabilise and get closer and closer to just one specific number. We also said that the way we examine the behaviour of a sequence infinitely far down the list is to take the limit as n tends to infinity. But if the list of numbers does not stabilise or does not approach just one specific number, we say that the sequence diverges. So we'll begin with a formal definition of divergence. Okay, so we said that a sequence an diverges if the limit as n tends to infinity of an is equal to plus or minus infinity, or the limit as n tends to infinity of an does not exist. So let's have a look at an example. Let's consider the sequence an where the n term is given by 2n plus 1. And we'll begin by writing out the first few terms of the sequence. Okay, so when n is 1, we'll get 3. When n is 2, we'll get 5. When n is 3, we'll get 7. When n is 4, we'll get 9. When n is 5, we get 11. And so on like that forever. So just examining the first few terms of this sequence, it would appear that the numbers are just getting bigger and bigger and bigger. In other words, it would appear that the sequence is tending off towards infinity. But in order to prove that, what I need to do is I need to calculate the limit as n tends to infinity of 2n plus 1. Okay, so if I was to let n tend to infinity in this here, well, 2 times is just going to make it go towards infinity twice as quickly. The addition of 1 isn't going to really make a lot of difference. So in total, all of this is going to go to infinity. So now we can use our formal definition of divergence up here, and we see that we can now say that therefore our sequence an diverges. Okay, so let's have a look at another example. Okay, so this time let's consider the sequence an where the n term is given by minus 1 to the n plus 5. And just like the last example, we'll start off by writing out the first few terms of the sequence. Okay, so when n is 1, we'll get 4. When n is 2, we get 6. When n is 3, we get 4. When n is 4, we get 6. When n is 5, we get 4. And when n is 6, we get 6. And so on like that forever. So examining the first few terms of this sequence, it would appear that our numbers are just alternating. 4, 6, 4, 6, 4, 6, and so on like that forever. So hopefully you'll agree that if I was to calculate the limit as n tends to infinity of minus 1 to the n plus 5, we would discover that this does not exist. In other words, if I was to travel infinitely far down the list of numbers, I would not tend towards just one specific number. And the reason for that is because my terms are just alternating from 4 to 6, 4, 6, 4, 6. So once again, by a formal definition of divergence, we can therefore say that the sequence an diverges.